Hello, everyone, and welcome to today's presentation on combining SOAR and threat intel, where we will specifically be covering MISP automation. Before we begin, I want to go over a few housekeeping items. This session is being recorded and will be shared out with everyone after the completion of the webinar, so you can be on the lookout for that and rewatch at your convenience. Additionally, we will be hosting a Q&A at the end of this session, so feel free to ask questions throughout the entire presentation using the Zoom control panel at the bottom of your screen to ask those questions, and we'll help address those at the end of today's presentation. So with that, I would like to share who's presenting today. We have John Poon, who's the VP of Security Services at NovaCoast, a leading security service provider, along with Arno Luce, a technical account manager here at Siemplify, who has over 20 years of engineering experience and is our resident open source and MISP expert, if you will. So very excited to have them both here today. And with that, I will let both John and Arno take it from here.
All right, thank you. All right, so I am John Poon, VP Security Services at NovaCoast here. For those of you that might not be familiar with NovaCoast, figured do a quick introduction. We are an IT professional services company focused primarily in cybersecurity, and we've been doing this for well over 24 years, coming up on 25, I think, at this point. We started as an engineering firm and have grown over those 24, 25 years into providing managed services. And today we operate 4 global SOC locations on a 24/7 by 365 basis, while still providing engineering and security-focused software development services as well. And part of that journey and part of our work that we've been doing, we're always looking at trying to help organizations do more with less. So automation becomes a heavy piece of that, which is where we got connected with Siemplify as one of those premier SOAR providers in the marketplace today. And today, we'll go through a few examples, talking a bit about some technologies, MISP, obviously, as the TIP platform or as a threat information sharing platform, if you're unfamiliar. We'll talk about that, and then how it integrates with Siemplify, and we'll walk through a demo as well to understand how the two would integrate and how you could leverage the automation from a SOAR platform like Siemplify and the information from a threat intel perspective that would be held in something like MISP. Okay, so for those that are not familiar with MISP, it stands for Malware Information Sharing Platform, and essentially what it does is act as an IOC database for as well as threat intel for the different sources of information that you would obtain, whether that is something that's derived from an external feed, whether it's open source or something that's proprietary and paid for, or a lot of times the intel is also generated within a community or even within your own organization as your analysts and security teams are working with the incidents that you come across. The sharing aspect of this is also a big piece. So not only does MISP act as the IOC database, but it allows you to share out that information to other groups that you might have relationships with. A lot of times that this is going to be partner companies or other organizations, and we'll get into some of that. And it's got some really nice features to support all of those capabilities. So we'll dig into that a little bit as well to give you guys an understanding of some, almost like a quick start core understanding of MISP and some of the core concepts. But one of those things is also the ability to export. So one of the neat things that you can do is actually export some of those IOCs into some of the tools that you might have. So things like IDSs in particular, you can export as signatures to help in the preventative or at least the detect side of some of those tools. Okay, so MISP, let's talk about it in a little bit more detail, right? So one of the things is the ability to get threat information in somewhere, right? And that somewhere is going to be MISP. But like I said, at its core, it's essentially a database for you to store threat intel. Some of the key pieces of information, source IP, hashes, source emails, host names, and domains, right? So there's a whole bunch of other attributes, if you will, that can be associated with a particular event. But that stuff can be either imported programmatically, you can manually create these individual items, and then you can also bulk import. So it does have the ability to, like I said, bulk upload, if you will, for different sources of information. So once it's in, of course, you're going to be able to search against that information as well. So it's there. This can be deployed in a cloud environment. It can be deployed on-prem. It's very flexible, very scalable, and depending on how long you want to store indicators or how much threat information that you might have, you can scale out the platform accordingly. And then the last piece is the sharing aspect of this. So for most groups, they'll start and they'll simply consume threat intel information. And if you're a particularly large organization, MISP gives you a way to share that intel across to the other groups. If you have different divisions, if you've got different business units, if you're globally distributed or geographically distributed, and MISP gives you a nice way to share amongst the different groups. I know a lot of the more sophisticated or larger organizations these days are building fusion centers, right? So having a tip platform would support that ability to share the intel amongst your own organization. Within that, like I said, you can also then share to other organizations that you've partnered with. So again, sometimes this could actually be set up as if you're a holding company and you've got a lot of different businesses that operate independently, they could each have their own instance of MISP and share the information amongst themselves. The nice thing about this also is there's other intel communities out there, and of course, as they gather information and intel through their different sources, that can all be shared across as well. So amongst their own communities, and then as a community on a large, on an even larger scale. All right, so oh, right, and then of course there's an API for MISP which allows you to interact and automate. And today we're going to be focused on Siemplify and the interaction through APIs are there. Okay, so the threat intel itself, you can think of each of these as an entry, and there's going to be a bunch of attributes that will basically describe and provide information associated with that particular entry. So there are things like categories. This could be things like network. It could be payload delivery. It could be completely opposite of that and be more of a person or a social network. The idea is here is you're categorizing the piece of intel into some domain. And then within that, you're going to have types. So depending on what it is, if it's network, right, you might have a URL associated with it. If it's a person, you might have passport information associated, and so on and so forth. So the different categories will have different types of data that you can populate. And then there is a distribution flag. So whether this is something that you want to keep internal, or if it's something that could be distributed out to a wider network, you've got the ability to restrict that. And then there's the value itself. So, if it is a URL, what the URL was, right? And these don't have to be singular values. They could be multi-valued. And that information would get populated depending on what the indicator or what that piece of intel was. There's also the concept of a tag library. So, there's a number of out-of-the-box tags, and these tags you are literally click, drag and drop kind of tags. So you would pull from a library to further tag different entries. We'll cover that here in a little bit. There's a few ways to do that. And then, again, if you export it out, right, you can export these to IDSs, for example. So hash lists are a great example of that. If you've got known web malware matches a certain hash, you've seen it on your network, right, you could export that out into an IDS signature and have it blocked. The whole platform is also designed to be very scalable and flexible and customizable. So what that means is all of these attributes that we're looking at here, the tag libraries, you can create your own in addition to what's already available in the platform itself. Okay, so let's dig into that a little bit. So the event, we talked about classification. The way that these are set up is into different taxonomies. And again, there's a number of these available out of the box. And it's very simple. It's a namespace which identifies which taxonomy you're using. It's going to be a predicate, which is a fancy name for the name, right, or what you want to call it, and then the value, which is the value itself. So if we pull one out on the interface in MISP, when you're looking at a particular event, if we use the Admiralty scale, one of the things you're defining there is going to be the source reliability. And in this case, it would be fairly reliable as the value for it, right? So that's how that breaks down. On the back end, for the system-to-system integration, there's the concept of a machine tag. So the exact same piece of information. Now you see there's no there's no spaces there. It's dash separated. It's all lowercase, right? And the fairly readable gets translated to an alphabetic, the letter C in this case. And so the idea is that you as an analyst can see the information on the interface, and it's presented in a way that you can read, but then it's also associated on the back end for that machine-to-machine communication. So it's easily parsed. It can be leveraged in other platforms, as we'll see later on. To help hammer this home, I know Admiralty scale, right? That was the example we used here to put another taxonomy in there for you. A lot of people are familiar with the traffic light protocol, right? TLP. So if you're going to go TLP red, right? In this case, it's very straightforward. There's only a name value pair as opposed to having a namespace in there as well. So some of the taxonomies may differ very slightly in structure, but they all pretty much follow this. Again, the taxonomies are all documented, they're known, and for them to be effective, it's actually important for at least your use within the organization to utilize the same taxonomies. So if you do develop a custom one, which you can also extend the existing ones if you find a reason to do that. This is all available. It's all very basic, simple config files that you can update. They're all JSON formatted, right? So very standards compliant and easy to understand and read. But it's important as you guys go through selecting the different taxonomies you want to use to make sure that at least within your company or your sharing circle, you guys are utilizing the same taxonomies, right? Because if you're going to be trading intel back and forth, you want to make sure that the taxonomies you're using to classify an event match what somebody else is using, so you can benefit from the information that they find. This also plays into sightings, right? So if you're taking information in from a feed, sometimes that could be out of date information, or there's new information available based on what you're seeing. And so you can tag that information, and the sightings will help you manage the event within the system as well. So if you have indicators that have come, they haven't been cited in over whatever 100 days, right? Maybe you want to remove that from the system, or at least the analyst, when they're looking at that indicator, can make that determination. Okay, this thing's at least 100 days old or more. Maybe it's not as reliable, right? The DNS name probably isn't valid anymore. So it helps in that respect. Beyond that, there's also what's known as galaxies and clusters. So here, galaxies are basically a way to organize clusters, clusters being the information itself. So if we think about galaxies as threat actors, right, and within that, this is obviously an abbreviated list, but the clusters would be things like Sandworm, Scarcraft, Scarlet Mimic, right? So the different threat actors that you have intel on. And then if we dig into one of those, let's take a look at Sandworm, right? Again, this is abbreviated. There's much more to it, but you get a feel for the entry itself. So there's a description, right, of what this threat actor is known to do. You get a confidence score as far as attribution, and the attribution in terms of the information that is detailed below here. You get more information, things like is this a Russian Federation, state sponsored, who they typically target, other names that group might be known as, right? And there's a lot more. There's toolkits, there's links and stuff that take you to more information that's published about this particular threat actor. So again, the clusters are collections of information, and then all those being grouped into galaxies. And again, in your sharing circle, depending on who you're sharing with, you're going to want to use, right, similar or the same at least galaxies and clusters there, so that as you trade information back and forth, it lines up and it's consumable and you don't get duplicate entries there. If this is a little bit too abstract, or maybe to pull an abstraction out, you could think of this in something more pedestrian, right? So if you're describing cars as a category, right, or we call that our galaxy, then within that you have different cars, right? So Civics, Camaros, and the Model S. And then again, within that is the actual information. So looking at the Model S, you might describe it as being manufactured by Tesla, and they got different models and so on and so forth. So it's a way to group the information in a way that you can then search it. All right, so with that, the other thing that I didn't call out before we jump into the next section here is that with those classifications, that also allows you to then filter what you're sharing. So you can define sharing rules. So certain bits of intel you don't want to share out, right? It could be attributable back to your group or your organization or specific systems. So the tagging and the classifications and taxonomies and whatnot, they help you with that filtering rule set to be able to quickly search and then also quickly filter on what you feel comfortable sharing and how it should be shared. All right, so in the next section here, let me kick it over to my counterpart, Arno, who's gonna go through a demo of Siemplify and that integration with MISP. And for those here that are attending, we've actually put together a quick start for the MISP platform. So if you've never used it before, you're unfamiliar with how TIP platforms work, we put together a quick start where we'll go ahead and deploy this for you. It's a containerized solution. We'll manage it and keep it updated if you need it. And then also act as a resource for you. So if you do have questions, you can reach out. You'll have a point of contact for that as well. All right, Arno, on to you.
All right, thank you, John. Very well said. Welcome, everyone. My name is Arno. I'm a technical account manager here at Siemplify. And really today, I'd like to present for you a couple of use cases that we've developed here regarding MISP. For those of you who are unaware, Siemplify is currently the #1 independent SOAR platform. We have the ability to go ahead and integrate with really hundreds of applications or across a wide variety of product categories. And MISP is one of the many integrations available to combine TIP and SOAR, really allowing for a more thorough investigation to occur within the platform. So with that said, we can go ahead and move on to the demo, and I will share out my screen. All right, so here we have 3 different use cases to present. The first really regarding MISP enrichment, our second one around pivoting and investigation, and our third with ingesting IOCs from MISP. So what we have in front of us here is a suspicious phishing alert to which we've gone ahead and attached a playbook. Really what we can see here is we go ahead and we start doing some basic user enrichment, in this case from Airtable versus Active Directory, and we go ahead and call out some user information regarding the user that's affected. We then go ahead and we move on to the next action, which is really searching MISP for across all the entities that are attached to this alert. And if we go ahead and we click on this action, we can see that indeed we have a match with the hash that's been included. We then move on to an event, a MISP event processing block. And this block really then goes ahead and pulls the latest related event ID to the match that has occurred and allows us to go ahead and bring in some additional contextual information. Now, as part of that, it also goes ahead and calls out this insight that displays some of the information that's pulled back in a very readable format for the analyst. And a couple of things that we can see here is the threat level for this particular indicator has been assigned a level of high. Now within MISP, we have a threat level ID, which is a numerical value. And through the templating that's generating this insight, we're actually going ahead and translating that numerical value into something that's more readable for the analyst. The other thing that I'd like to go ahead and call out on here is we can see that we actually had 2 galaxies that were attached to this particular event. And that's gonna come back into play here in just a minute. And now once we've gone ahead and we've pulled back some related event details, here we're really just going through 2 virus total searches, one for scan URL, one for scan hash. And then we're hitting a conditional that is checking to see if in fact there are galaxies that are attached to this event. We then have 3 different enrichments for 3 different galaxies. And we can see here that, excuse me, going back for just a second to our insight, we can see that we had a match for threat actor and attack pattern, but not one for tooling. And so that went ahead and allowed us to go ahead and call out some additional details on the MITRE attack technique that was included here. And then as well as an insight giving some additional information regarding the threat actor. If we come back to our alert, we can go ahead and we see that we've also gone ahead and mapped some of those as entities on here. And really that is the enrichment use case. So if we go ahead and we move back up here to our investigation use case. Let me go down and find my notes. So our second use case takes the results essentially from the first use case, adds these new entities to the alerts, and then includes them as part of the investigative process. So we can see here that really this playbook begins in a very similar fashion to the first playbook. It creates the MISP event details insight in the MISP event process block. And then that takes us to here. And then we can see that we actually use our Jinja templating integration, render template, to go ahead and parse the JSON results with some Jinja templating applied to it, to really then go ahead and pick out the individual values that we're interested in. In this case, a specific IP address that's being returned. And in our next render template action, we actually go ahead and call out or group the hashes together that were returned as well. We then go through and we're able to go ahead and create entities out of the new values that were returned. If we now go to our Entity Explorer, which is the blue button in the top right-hand corner, that brings us this page. And we can really see here that we have the ability to go ahead and visualize all of the different entities that were included as part of the original alert that was ingested. And then we can see if we go ahead and click off that we have in fact added a new host, a new IP, as well as 2 additional hashes, but that they don't necessarily at this time have any linked relationships as defined within Siemplify. And so then after we then go ahead and really begin our hash and IP investigation blocks, in this case using Sentinel-1 and Splunk. And so we're able to go ahead and run a deep visibility search within Sentinel-1. We read the results, and then if the total item return count is greater than 0, we go ahead and parse them, render an insight, and create an entity. We're able to see here that we're able to parse out that information as well as the host name, the endpoint that was identified within there. And then really our last block here being an IP investigation goes taking us through a Splunk search for some additional context. In this case, not calling out any specific results. And obviously I do want to call out at this point that, at this point in the playbook, the investigation can go ahead and branch into a number of different directions. It's by no means limited to the specific actions that I've called out here. We can go ahead and take the investigation anywhere we want at this point. Going up to our use case number 3, our third use case shows us the ability to ingest recently added IOCs through a connector, and then we block them. So I just want to take a second to go ahead and look at the connector that's being used here. We see that it's got a lot of the standard fields, as well as we have the ability, excuse me, to identify the types of artifacts that we want to go ahead and ingest, as well as provide some whitelist rules to really just focus in on only ingesting perhaps attributes or artifacts with some specific tags attached to them, for instance. That then goes ahead and takes us back to our alert. We can see here that at the event level, we've gone ahead and pulled in 3 events, one of them being a URL, one being an IP source IP address, which is the root IP from the URL, as well as 2 additional hashes. And then really we come in and we call a playbook, which goes ahead and adds those to 2 separate blocks. So we can see here that we go ahead and we add the IP address to a checkpoint block list, and then we go ahead and we do the same thing with the URL as well. And that goes ahead and highlights 3 somewhat simplistic use cases within the platform that can obviously be expanded on, but that really harness and showcase the ability to pull back those related IOCs, pivot an investigation and even pull in more relevant detail that wasn't necessarily included with the original alert, which was ingested. Hopefully, you're able to go ahead and take these templates and build upon them and build something truly wonderful for your organization. All right, with that, I'm going to go ahead and stop sharing out my screen. All right, John, back to you.
All right. I think at this point, if there's no other questions, we will, or sorry, there's no other content, so we can open it up for questions is what I meant to say.
Awesome. Thanks, John. And thank you, Arno, as well, for the demo and showing off those 3 use cases. So as mentioned, we have a few minutes left here, so we'll real quick get to a Q&A. So feel free to ask those questions using the control panel at the bottom of your screen. But kicking things off, someone would like to know that if they're already using another threat intel solution, can you recreate those same playbooks, those same use cases using another tip platform?
Yes, you can actually. So the interaction that we showed today with MISP, I mean, that's an open source tip platform. I mean, it works fine. It works well if you don't have one. If you've got a different one, the same integration and the same workflow and interaction that we talked about here today could be done with a similar integration with any other tip platform, really. So there's a bunch out there. They've all got APIs that actually enable the same workflow that we just went through here today.
Awesome. And another question for you, John, actually, someone would like to know how long it took you to get up and running with SOAR and with Siemplify and what that process was like.
Yeah, so if you have never worked with MISP before, let's see, let me just get this slide back up for you guys. So if you've never worked with MISP before, it is, for the most part, like I said, a containerized solution. So if you're not familiar with that, it might be a little bit challenging, but they do have different distributions, whether you want to, being open source, you can build it from source. Like I said, they've got a containerized version of it. You can also simply install if you want as well from install scripts. So it's very flexible in that respect. Getting it up for the very first time, realistically, a day or two if you're not familiar with containers. Might take you a little bit of research. It does run on Linux. So if you're not familiar with that, if you're primarily a Windows person, again, that might be another challenging curve for you there. But it should be pretty fast. I mean, it's a day or two to set up. There are a number of open source feeds that are available for it already. So you could simply plug into those sources. And like I said, most groups who are utilizing tip platforms subscribe to, at least one, if not a couple different threat intel feeds that also provide information, via Stix, Taxi, and other formats. So depending on that, the integrations are fairly quick as well. So all the big ones are supported, and it's pretty fast to get that off the ground. So realistically, if you're starting from zero experience on Linux and containers, it would maybe take you a week.
Awesome. Thanks, John. And for the next question, I'll quickly address it and then feel free to add anything additionally, Arno. But someone would like to know if we have a out-of-the-box MISP playbook available for Siemplify. And currently, the MISP integration is already there and ready for download. As far as an out-of-the-box playbook, we're in the process of publishing pretty much what we showed today to our playbook / use case marketplace. However, we do already have a ton of other use cases published in our marketplace that you can deploy in literally seconds. And those are all, or at least some are dynamic, in which case you would put in what threat intel solution you're using or what, EDR solution, for example, you're using or firewall. And all of those use cases are pre-built. But if you have anything else to add, Arno.
No, that's absolutely correct. The playbooks that I went ahead and showed today will be released in the use case marketplace. Probably not the third one with regards to the connector because it's so simplistic. And then when I showed the enrichment and investigation use cases, the investigation use case encompasses everything that's done within the enrichment. So we will be releasing the investigation playbook into the use case marketplace.
Awesome. Thanks, Arno. So with that, I'm going to wrap up the Q&A. Before we go, I did just want to quickly highlight the Siemplify community. So you can actually, it's not open source, but it is free. If you go to siemplify.co, if you're not already using our solution, we do have a community version that again comes with ready to deploy use cases, allows you to build out your own playbooks, integrate your own tools that you're already using, respond to your existing security alerts. And you can also, as part of downloading the community, you join our literal community where there are a plethora of security operations experts who are constantly discussing SOAR and just all around best practices. So feel free to check that out if you haven't already. And from here, I want to thank John and Arno both for giving this fantastic presentation. And I want to thank everyone else as well for joining us today. We really appreciate it, and I hope you enjoy the rest of your afternoon.
All right, thank you so much.